Hello, in this video I will be proving that there are infinitely many primes. So in this video we need to first look at a few prerequisites, mainly being a few definitions, a useful lemma, the fundamental theorem of arithmetic, and then the proof that we want to do. Starting off with our definitions, we firstly define the integers. Now the integers are essentially the set of whole numbers. This includes the negative numbers and 0. The natural numbers, a subset of the integers, only contain the positive whole numbers and do not contain 0. Now, we say that for a and b being integers, that a divides b, denoted as a bar b, if there exists a integer n such that b is equal to an. We call an integer p a prime if p is greater than 1, and whenever a natural number, divides p, we must have that a is equal to 1 or a is equal to p. This is equivalent to saying that for p to be a prime, it has to be greater than 1 and is divisible only by itself and 1. Now, looking at the useful lemma, take a, b, and m being integers. If m divides a and m divides b, then we must have that m divides lambda a plus mu b, for lambda and mu being integers. Let's prove this. If m divides a and m divides b, then there has to exist an x and a y in z, such that a equals mx and b equals my. Then let's take two integers, lambda and mu, and let's take a look at lambda a plus mu b. Now, with our new values of a and b, we know that's equal to lambda mx plus mu my. We then factorize m to get m times lambda x plus mu y, which then satisfies our divisibility definition. So we then have that m divides lambda a plus mu b. We now look at the fundamental theorem of arithmetic. Every integer that's greater than 1 can be written uniquely as a product of primes. Another way of saying this is that for all integers m satisfying that m is greater than or equal to 2, there exists a group of primes p1 to pk such that the product is equal to m. Now we're ready to prove that there are infinitely many primes. We'll go about this proof through contradiction. We first assume that there are a finite amount of primes, and then through that, we then try to find a contradiction or an inconsistency in the maths. The reasoning is, if we do find that contradiction, then the assumption of having finite primes must then be false. That means that the opposite is true, which is that exist infinitely many primes. So we start off with this proof by assuming that there are finite primes p1 to pk, where k is a natural number. We then define a number n to be the product of those primes plus 1. Notice that n has to be greater than or equal to 2, mainly because all the primes are greater than a 1, so that means the product has to be greater than 1, and we're also adding 1 to it. That means n has to be greater than or equal to 2. And this satisfies our assumption of the fundamental theorem of arithmetic, which is that n can then be written as a product of primes. But remember that our primes are finite. So if n can be written as a product of these primes, then it must be divisible by at least one of those primes in the list. So we just choose one of those primes, which is pj, and we say that pj divides n, because we know at least one of those primes does divide n. Remember that pj also divides the product of all the finite primes, because pj is also included in that product. So now, using the useful lemma, we find that pj divides n minus the product p1 to pk. But let's look at what that is. What is n minus p, the product of p1 to pk? Well, that's just equal to 1. So that means pj must divide 1, which then implies that pj is equal to 1. The reasoning for that is any number that divides 1 must then be equal to plus or minus 1. But pj is positive, so then pj must be equal to 1. But then that's a contradiction, because pj being prime means that it is greater than 1. So there it is, our contradiction, which then means that there exist infinitely many primes. If you made it to the end of this video, then thank you for taking the time to watch it. It's been a pleasure to make it. If there are anything that's confusing you or you want to ask, feel free to put in the comment below, as well as any other maths contents that you want, and I'll definitely make a video on it. Thank you for watching. Bye bye.